In this video we're going to take a look at the highest common factors and lowest common multiples of a set of numbers, and we're going to have a look at how to find them as well. So to start off with, I've typed out the definitions of both of these terms at the top, so have a read of those and I'll explain to you how to find them and what they look like. So if we start with two numbers, let's say 12 and 18, we know that these two numbers can be split into their factors. So 12, for example, that is 1 times 12, or 2 times 6, or 3 times 4. Now 18, that can be 1 times 18, 2 times 9, and 3 times 6. So these are the factors of my two numbers. So looking for the highest common factor, well, that just tells me what I'm looking for. It's the highest factor that the two numbers have in common. So let's pick out the factors that they have in common. We change colour. We have the number 1. We have the number 2. The number 3. And finally 6. So out of those, which number is the highest? Well, obviously that is 6. So we found our highest common factor. Now let's have a look at the lowest common multiple. So the multiples of 12, let's multiply 12 by 1. That's going to give me, obviously, 12. Multiplied by 2, that's 24. And if I just keep going, times by 3, times by 4, times by 5. And I think I'll stop there. I've got enough numbers. So let's do the same with 18 now. Let's find the multiples of 18. So 18 times 1 is 18, times by 2, times by 3, and so on. I've already got enough multiples there. And all I need to do is find the multiples that they have in common. And in this case, we want the lowest one because we're looking for the lowest common multiple. So in this case, that is the number 36. So that is a simple method. Not the quickest, but it's a foolproof method. As long as you know the factors and the multiples, as long as you can work those out, then you should be able to find the highest common factor and the lowest common multiple. So there's 3 pairs of numbers here. And if you pause the screen now and have a go at finding the lowest common multiple and the highest common factor, I'll show you the answers. And there you go. If you have any questions about those, just leave them in the comments section down below. So our second method for finding the highest common factor and the lowest common multiple involves prime numbers, more specifically prime factors. So any number can be composed of a certain set of prime numbers multiplied together, apart from 1 and 0 and the negative ones. But all of the positive integers from 2 upwards can be composed of multiplying 2 prime numbers together. Obviously, we're not talking about prime numbers here, any other number. That is. So say, for example, 4. That can be composed of this prime number here, 2. So that is 2 times 2. So it's all prime numbers multiplied together. Let's pick a bigger one. Let's pick something like 51. Well, that there is going to be 3 times 3 times 7. So as you can see, all prime numbers multiplied together. So we can use this fact to help us work out the highest common factor and the lowest common multiple. So again, let's pick a set of numbers. Let's use what we had. Let's use 12 and 18. And what we're going to do is we're going to separate these numbers into their prime factors. So the method that, well, at least I use to do this, is I go from the smallest prime number and work my way upwards and see if that prime number is a factor of my bigger number. So 12, let's pick 2 to start off with. Well, does 2 go into 12? Yes, it does. So I draw my left-hand branch and I have a 2 there. And if I'm dividing by 2, what's left over goes on my right-hand branch, and that's a 6. And then I repeat the same method with 6 this time. So does 2 go into 6? Well, yes, it does. And what's left over? It's a 3. Now at this stage, I know that 3 is a prime number, so it's time to stop. I've found all of the prime factors for 12. So 12 is equal to 2 times 2 times 3. And you'll often see it written as 2 squared times 3. You like to simplify this 2 times 2. There's a little indices subscript there. So there we go. That's how to find the prime factors of a number. Now let's try that with 18. You could pause the video, try it yourself. So does 2 go into 18? Yes, it does. What have we got left over? Well, that's a 9. 9's not a prime number, so let's keep going. Does 2 go into 9? No, it doesn't, so I move up my list of prime numbers and I get to the 3. I check if 3 goes into 9. Well, yes, it does. And what I'm left over with is 3, which is another prime number, so I know to stop. So 18 is going to be equal to 2 times 3 times 3. And obviously I can write that as 2 times 3 squared. So I've broken 12 and 18 down into their prime factors. So what we're going to do now is we're going to use those and we're going to fill in a Venn diagram. So this left-hand circle is going to represent all of the numbers, all of the prime factors of 12, and this right-hand circle is going to represent all of the prime factors of 18. So inside this circle we're going to have 2, 2 and 3, and inside this right-hand circle we're going to have 2, 3 and 3. So how are we going to fill it out? Well, this middle section has got to be the intersecting section between these numbers and these numbers. So if we look at what they both have in common, well, they both have a 2 in common. So there's a 2 there, and there's a 2 there. So what we're going to do is we're going to put it in the middle, and that means it's both in the left-hand circle and in the right-hand circle. So moving on, let's have a look at this second 2. Well, this doesn't repeat itself in 18's prime factors, so it must live by itself in this left-hand circle. Notice I'm crossing these out as I go along, so I don't repeat any of these factors. So now this 3, well, there's another 3 over there, so we can take those and put them in the middle. And this 3 here, there isn't another one with 12, so cross that out and we put it in the right-hand circle here. So there we go. I've distributed the prime factors of 12 and 18 into these 2 circles of my Venn diagram. So if we think about what highest common factor means, we're looking for the highest whole number which divides into both 18 and 12. And we know that all of these numbers here, well, at least these numbers in the left-hand circle all divide into 12, and the numbers in the right-hand circle all divide into 18, which means the numbers in the middle must divide into both of them. So a common factor between 12 and 18 could be 2, or it could be 3. But if we multiply the middle 2 together, we get a number which divides into 12 and divides into 18. So for the highest common factor, what we do is we take the middle numbers of our Venn diagram and we multiply them together. So 2 times 3 in this case, which will give me 6. Okay, now let's have a look at the lowest common multiple. So if I multiply these 3 factors in the left-hand circle, I'm going to get 12. If I multiply these 3 numbers in the right-hand circle, I'm going to get 18. So what I'm going to do is I'm going to multiply all of these 4 prime factors together. So for my lowest common multiple, I'm going to do 2 times 2 times 3 times 3, and that is going to get me my lowest common multiple. So that's 4 times 9, which is 36. So we're not repeating this extra 2, which is in the middle, and we're not repeating the extra 3, which is in the middle. We're not just multiplying 12 by 18. We're seeing what they have in common, we're seeing what each of them have separately, and we're multiplying all of those prime factors together to get our lowest common multiple. So using that prime factors method, there's another 2 pairs of numbers here for you to have a go at finding their highest common factor and their lowest common multiple. So if you pause the video now, and I'll show you the answers, and there are the solutions for those sets of numbers. If you have any questions about anything in this video, or any other maths question that you want to ask, feel free to leave it down in the comments section below and I'll get round to answering you.